everyone. Before I start the lecture, do you guys have any questions? Concerns? Everything's good? Okay. So as you saw last session, I started to encourage class participation and give extra credits for that, and then you receive 5 points just by volunteering to solve a problem, and then you don't have to answer it correctly as long as you just like put the effort to come here. And also, as I said several times, I'm going to assign, and I'm basically giving you extra credits for going to tutoring. And I have like these communications with Dale and also your tutors to make sure they know all the course materials, and then they are up to date with the exam, homeworks, and everything. So you get the most out of the tutoring sessions. And also, I started to assign extra credits for just coming to my office hours and discussing things for 1 hour, basically tutoring with me in a sense. And I'm going to have more office hours next week before your exam. So just keep an eye out for the announcements that I'm going to send. Probably Monday at 4 or 4:30, right? Does that work for most of you if you want to ask questions? And also Tuesday morning probably, and Tuesday evening. So you all have the chance to ask me your questions. And also, if you're lacking some points, this is a good opportunity to get just extra credits. And the way that I do that, for 60 minutes, I assign 5 extra credits. So if you come to me for 40 minutes, or I just have the ratio and then I convert the points, so you don't have, and I also check with you, so I make sure I'm not making any mistakes. So with all that being said, I feel like all of you can get an A in the class, because even if you're lacking some points, by going to tutoring or coming to me, you can make up for the points that you have lost. So yeah, any questions so far? Yes?
Will you be releasing a practice exam?
The practice exam. I'm going to
Or practice
post
questions, I should say.
Yes, I mean, your exam would be really similar to your homework problems and also the extra credit practice quiz that I posted. And it's kind of interesting that I have 2 students that they're following the class online because they had their own reasons, and they watch the lectures every week, and I'm following up with them, making sure that they know the materials. And those 2 students were the only students that reached out to me that, can you send me the practice quiz 3? Because I told you that I didn't post that on Canvas, so I make sure students watch the lectures. And on average, we have 45 students in the class out of 60, so there are 15 students almost that they don't watch the lectures, don't come to the class. Maybe they know the materials, but they're going to have, problems. And I'm going to reach out to them after I count all the attendance during the weekend. But yes, I'm going to post a study guide. And I'm also going maybe I add some questions to that too, but as long as you know all the homework problems and all the quiz problems, I think what I'm going to do, I'm going to record a video of problems that most students had difficulty with and explain those. So you have lots of questions. Yes.
Is the extra credit points that if we've gotten, will they be posted soon or at the very end?
The grades?
Yeah.
So surprisingly, there were roughly 25 of you that sent me the extra credits, which is again, interesting to me, because it's just 20 free points and you had the solutions, right? Anyway, so I guess I can manage to just grade them and kind of look at them.
I was just curious.
Yes, and I think I add them, before or after your exam. For your tutoring, I'm going to, so I added extra credits for tutoring before entering your midterms, but some of you, if your grade, for instance, was 75 and then it increased to 78, your grade still was C, so you couldn't see the difference. But some of you that had 78 or 79 and you went to tutoring, you saw B on midterm. So I included them for your midterm, and I'm going to include for your finals. But I'm going to get a spreadsheet from Dale with all the attendance, all the hours and all that. So that one, I just take care of it at the end of the semester. But for your tutorings with myself and what else? For the extra credits that you sent me, I try, and then the class participation, I just add them, next week. I mean, I already added class participation last week, but for the 20 points extra credit, I also add that, so you see your grade higher, and I think it always feels good. Yeah, thank you for the questions. Any other questions before I start the lecture? Yes?
For like the last exam, you went over like quizzes and homework scores on like you went through like why they were wrong and like how to solve them. Are we gonna get like an opportunity to do that in class again before our exam on Wednesday?
Okay, so how many of you like me to do that? To go through the... Okay, so I'll do that. Okay, so on Monday I'm going to go over the materials. Sometimes I tend to over-explain things, or I feel like sometimes, some students know the material, so they prefer I do that outside of the class, but since most of you would like me to do that, I'll do that. So you'll be prepared as much as possible. Yes?
Will there be a study guide posted?
Yes, I'm going to post a study guide too, yeah. I have like my other class, I have the exam on Monday. So I try to write the study guide during the weekend, but if something happens and I cannot do that, I'll try my best to have it by Monday. So, but I try to do it during the weekend, so you have like weekend to study for your exam as well, or like study the study guide specifically. Great question. Any other questions? Good. Okay, so I'm going to continue with chapter 4, aromatic compounds, that we started last session and the session before. I just told you this is benzene. That's all I told you, basically. And in order for me to progress with this book, I'm going to cover certain materials, because if I just want to cover like each section word by word, if department chair asks me that how many chapters did you cover, if I just say 4, maybe it seems like I wasn't doing anything, but I was doing, I was just making sure that you learn. So I'm going to pick and choose, the sections, and I try my best, and I did that so far. Write the section so you know which section you should study. And as long as you, come to the class, look at the slides and all that, you know which part of the book you should study for your exam. And I don't ask you anything that I didn't talk about in the class. So if you go, and I probably, you have a test bank for your book. I'm going to also post questions from your test bank that you have like more resources to study. And if you see a question, I try to eliminate the ones that are not related, but sometimes if you see a question that we didn't talk about in the class, so it seems so unfamiliar, or like a name of reaction that you never heard of it, you don't have to worry about it. I just ask from the things that I covered in the class, okay? But it won't be maybe we talked about naming, I don't know, certain alkenes. Maybe I give another type of alkene. Like if we talked about like 2-butane, maybe I give you like 3-butane in the exam. Does that make sense? But I don't give you, I don't know, acetaldehyde that I didn't talk about in the class. Does that make sense? Okay. So let me take care of attendance at the end of the class, and let me progress with the lecture. So can anyone remember, let me have like, coming back here, we introduced benzene, and as I said, if you want, to give a presentation in conferences or like later on in your courses, I was thinking to have like a presentation or like group activities for this class, but this is still like a 200 level course, and I don't want to make your life harder than it is. And I just want you to focus learning materials. But when you go like to next year, or some of your seniors, and you give presentations in your classes, or when you have job interviews, sometimes they ask you to make a presentation. And this is not being considered a good slide. You know, when you give a presentation, you should have a slide that has figures so your audience don't start reading what you're writing, right? But I'm writing everything because you have as much as information as needed. And although I have the textbook mandatory, I know some students still don't have it. So at least they have as much as information as possible on the slide. So that's why I'm writing things on this slide. But I just like want you to know for life that when you want to make a presentation, you know, don't have only text. This would be distracting to your audience. Anyway, so remember that the formula of benzene is C6H6, and you should be able to, you know, draw this structure as well, remember. And these ones alternate, right? You have carbons here, and then you have just one hydrogen attached to that, right?
Does it matter where we put the double bonds? Like,
No.
if they're, at least if they're alternating? Does that make
Exactly,
sense?
as long as they alternate, you can just put it however you want. Okay, and as I just mentioned, benzene is a parent of a class of substances that we call aromatic compounds. And we call them not because of the aroma or smell, because they are really, you know, stable. Okay? And now, in this chapter, we want to learn why benzene or aromatic compounds in general, they are really stable, right? Don't they have double bonds? And didn't we say that when we have double bonds in alkenes, we have, do you remember what type of reactions we had when we had like double bonds in alkenes? Addition, exactly. Remember? So we had like substitution in the previous chapter for alkanes, and we had addition for alkenes. So now we want to know what type of reactions they undergo. Is it the same with alkenes? Are they stable? Are they not? And these are like the things that we're going to cover in this chapter. Is that clear somehow? The structure. Okay. Now, again, you know, I have like the sections here, so you can go to the book and study that. And if you have any difficulties with the book, please let me know. I contact the bookstore for you or like the publisher, and then we figure that out, okay? And if I ask you what is the ratio of carbon to hydrogen in benzene?
1-to-1.
Exactly, so it's 6 to 6, which is like 1, right? You just count the number of atoms. And as I just showed you previously, and 1, 2, 3, 4, 5, 6. So just make sure that they have like 6 carbons, and it will be C6H6. And do you remember what type of hydrocarbons were hydrocarbons that had double or triple bonds? Were they saturated or unsaturated? Unsaturated, right? If we only had single bonds, we had saturated. If they had only they had also double and triple bonds or multiple bonds, we call them unsaturated. And just looking at this structure is highly unsaturated, right? We have like 3 double bonds, and we have lots, you know, compared to other compounds that we studied before, like hexane or, you know, cyclohexane. We had like much fewer hydrogen atoms attached to carbon atoms. That's why it's highly unsaturated, right? And yeah, basically, you know, here we just compare benzene with like other unsaturated or saturated compounds. So hexane, remember, hexane and cyclohexane, they are like, you know, saturated. And also, just by looking at the formula, remember that if I give you like C6H12, remember that the structure can be saturated or unsaturated, and we had different isomers. Remember, we saw one example before, and your book has that problem too here in this chapter, that write as many as a structural formula as possible for C6H12, right? And then one possibility is that not having any double bonds, which is like cyclohexane. The other possibility is that to have like double bonds, right? Remember? So if I just give you the formula, remember that the structure can be saturated and not having any double bonds if you have like a ring. Are you following me, what I'm saying? Okay. And again, I included, so if you just read the, chapter, maybe, I don't need to explain everything that is written in the book, but I included this because I'm going to ask that in the homework assignment that I'm going to write this weekend. Before I go to the next slide. Sure. Back to, yes. Okay, any questions? Okay. As I just mentioned, we had for alkenes, and we learned that in the previous chapter, we had addition reactions, right? You may think that benzene also has, 3 double bonds, so it also goes through addition reactions, right? But the reality is that it does not. And as I mentioned, because it's really stable, it has a really stable structure. And the reaction that it goes through is by substitution. So it acts like alkanes in a way. Okay? And now we want to learn why that is and then how to write the substitution reactions for benzene. And I highlighted this sentence because, again, I'm going to ask you that in the exam. Or exam and homework. And just to be clear, anything that I cover today would be also on the exam. So as we agreed with the vote of all of you, most of you, we're going to have a review session on Monday. And I guess that's a really good opportunity for you to gain extra credits because I write some questions and ask you to come, try answer it so I see what is the problems some of you are facing or most of you. So it's a good opportunity to come to the class prepared so you gain extra credits. And as I said, you don't have to answer the questions correctly as long as you participate. Any questions so far? Good with this? Okay, now we want to study substitution reactions in benzene. So if you have benzene, which is C6H6, and then you react that with bromine, and if you remember from our other lectures and also your Chem 101 or other chemistry courses that you had, bromine exists as diatomic molecule, right? So it's Br2. And for this reaction, you should have also a catalyst for this reaction to occur. So remember, when you have Br2 or bromine, you should have, can anyone name this compound for me?
Iron bromide.
Iron bromide. Yes, almost. It just needs some other part too. Anyone know?
3.
Exactly, 3. So because iron can have multiple charges, we should specify what is the charge. Because it can, for instance, FeBr2, this is iron 2 bromide, right? So I'm not going to ask you naming compounds or naming ionic compounds in the exam, so you don't have to worry about it. And you can also name that ferric bromide, which is the old way of naming that. Let me just put this out. Okay. But regardless, you should have the catalyst, okay, for this reaction to occur. And can anyone tell me why do we use a catalyst? What is the purpose of using a catalyst? Exactly, because we want to speed up the reaction. Some reactions are really slow, and for them to occur and then be faster, we should use a catalyst, okay? And when you add Br2C6H6, you have bromobenzene, okay? And then we talk about naming aromatic compounds in the next slides, and HBr. So if you have, let me do this. 1, 2, 3, 4, 5, 6, and remember, you should alternate this double bond, right? Plus, and then for each of them, you have like a hydrogen attached to it. And you can write abbreviated structural formula or expanded as I'm writing. And then plus Br2 gives. So remember, we have substitution reactions. So if I want to substitute, one of these Brs with hydrogen, with, right? So we will be having still C6, 2, 3, 4, 5, 6, H5, which is 1, 2, 3, 4, 5. So, oh, I forgot one H here, right? So, 1, 2, 3, 4, 5, 6, and what did I have here? This, BR. Okay, plus HBr. I guess I changed this one. BR, so. And these guys. Okay, does that make sense? So,
Sorry.
yeah, no.
For an equation like this, would you always put that you had a catalyst?
Yes, yeah.
And
Thank you
for that specifically, could you just write catalyst, or would we be writing the iron bromide most of the time if we're doing like a substitution like this?
So if you know what is the catalyst, which one that you do is correct.
Okay.
Yeah.
But if you write just catalyst, that's okay?
Yeah.
Okay.
I mean, unless I ask you what is the catalyst.
Right.
Right. Great question. Any other questions? So when you have substitution reactions, you just substitute one of the, your hydrogens with this Br here, right? And then it doesn't matter which one you substitute, as long as you choose one and then substitute that with one of your bromine atoms, that would be correct. And you call this compound bromobenzene. And as I said, we're going to talk more about naming them in the next slides. But are we comfortable with writing this? Yes? Okay, so can anyone come to the board and then write similar thing that I wrote here for the next reaction? Yes, yeah. Use just zoom on this one. And remember, you don't write catalyst in the reactants because they don't participate in the reactions. They just speed up the reactions, but they don't form any bonds or they don't do any reaction. Yes.
I may be mixing my facts here, but when we did this before,
Uh-huh.
didn't we break one of the double bonds to do it, or is that just in the linear codes?
Exactly. That's a great question, and I repeat that for people who watch at home. That didn't we previously break the double bond and then add the, Cl2 to each of the, carbons? Can anyone answer this question? Yes? Exactly, that is addition reactions. This is substitution. So this is what we did for alkanes. Okay, can you also explain that to your friends?
One of the hydrogens is substituted with a chlorine,
Uh-huh.
and then the hydrogen that gets left bonds with the other chlorine.
Exactly. Is this clear for everyone? What was your name?
Patrick?
Oh, okay, perfect. Thank you. Okay. Is this clear? Questions? Okay. If no question, and I'm going to add that myself at home before posting the lecture, or like PowerPoint slides, I guess. So now, if looking at this structure that your friend wrote, this product here, right? Let me also write it here for people at home. So, or like I guess I can just explain here, right? So for the next part, this would be the same, just Cl. So if you look at this substituent here, does it matter, as one of your friends asked, that does it matter if I put this substituent here or here? Does it matter where I put it? Would the compound will be different? It won't be different, right? Because this is it has a symmetry, and wherever you put it, it would be exactly the same compound. So that's why we don't gain, or like, it's not, no isomers is produced when we have this specific reaction, when we have a benzene and add a halogen molecule to it. No isomers are obtained, because the result is just like the same. Do you remember that one question that I asked you before was like how many monochloro alkanes can be obtained in chlorination, and then the answer was like 1 in like previous chapters. So this is kind of similar, okay? And the result requires all 6 hydrogens in benzene to be chemically equivalent. So all of these, if you put Br here or here, it would be like the same. Now, let me see what I did. Okay, I'm still recording. 4, which is, bromo. Now, if you get the product that you had with benzene, right, and then add another bromine molecule to it, okay, now, just by looking at it, and then if you remember that if you do the same thing that we did here, right, and then you substitute another hydrogen with Cl or Br, depending on what question we're solving. In this case, in here, with Br, you'll be having 2 bromines, right? So let me demonstrate what I'm saying here. So if you have like this structure, and this is the structure that students can see on the board, right? So if you have this, and I tell you that now we add that again to Cl2, and we have another substitution reaction. So if you substitute this hydrogen also with Cl, right, and have this structure, do you think you'll be having isomers or not? You'll be having, right? Can anyone tell me how many isomers can be obtained? 3. Is that clear?
Can we see the 3?
Yes. Yeah. So, one possibility would be that your 2 Br atoms are next to each other, something like what I wrote in the previous slide, right? And then the other one would be like these 2 would be separated by one double and one single bond. So the other one, they had like only one double bond between them, right? And the other one is like one double, one single. And the other one is like double, single, double, right? Can anyone name these compounds? And you have like the answer on the board too, but like kind of explain to me why this is how we write them. Is that clear what I'm asking? So why do I call this 1 and 2 dibromobenzene? Why don't I say, 1 and 3, or like 1 and 2, 3, 4, 5, 1 and 6? Yes? Yeah?
Is it 1 and 2 is based on the points, hexagon, the bromine on the top,
Uh-huh.
first point, and bromine on the second point.
Yes. So basically we look at our substituents, right? And then we want to locate the position of substituents. So when you're dealing with benzene, we already know what is the structure of benzene, right? So we don't worry about telling or specifying the double bond location, because benzene has a universal structure that we just wrote here, right? You have like double and single bonds, and then they alternate. And for substituents, however, we should specify the carbon number and which carbons are attached to. So you just start with one of your substituents, call that 1, right? And remember that any direction that you go, you should pass the double bond, right? So you should go, this way, and then count, okay, if I call 1, this is 1, this substituent would be 2. So I cannot go the other direction because you should pass the double bond. Does that make sense? So you cannot, let me have this here, just like this. So if you have this structure, I just tell you that one of your substituents, you start naming there, okay? And then there are two possibilities, going this way or that way, right? And you should pass the double bond. So if you go the other direction, you started with a, double bond, but you didn't go to the direction that you passed the double bond. Does that make sense? Any questions? Okay, so with that, you say that 1, 2, 3, 4, 5, 6, and then you see where is your other substituent. So this one is the first one. So the second one is on the carbon number 2. So if it's here, you say that, okay, it's not carbon number 3. Or if it's here, you say number 4. So in this instance, it doesn't matter which direction you go. I guess you should still go this direction. But you can also start naming from this one. Anyway, is that clear for everyone? Yes?
So like hypothetically, if you put the VR on 6, we would go the other way, like counterclockwise?
Exactly. So if you put, actually that's a great question. Let me look at this. What if we put, so this is what you're asking, right?
Well, like if you only had the one on the side, like where 6 is labeled on the top one, and then you asked like where the other one was, would you go down?
So
If that was 1 instead of 6.
this one?
Yeah.
Okay, if this one was 1 and then this one was 6, or?
Like, is that the way you would go past the double bond first?
Yes.
Okay.
Yeah.
So like you go the opposite direction if the VR was
Exactly.
there.
Yes. Yeah. Great question. Any other questions? Okay. Okay. So if we have a ring like this, and we have, I asked you what is the formula or chemical formula of this compound. What would you tell me?
6H6.
Right? So any points that we have, right, we put a carbon. Remember that in organic compounds, to be more abbreviated, we don't write C's and H's all the time, right? But it implies that we have the carbons here. And what is the valence of carbon? 4, right? So it can form 4 bonds. So 1, 2, 3, 4. And then for each of these carbons, if you do the same and count, you have like 4 bonds, right? So 1, 2, 3, 4, 5, 6, C6, H, 1, 2, 3, 4, 5, 6, right? C6, H6. And we call this compound benzene. Okay? So
I thought that E and E was reserved for 2 double bonds. Isn't it 9? Double bonds?
So that's a great question. So what your friend is asking is that didn't we say that if we have 1 double bond, we call that alkene, or if you have like, if you have like 2 double bonds, we call that, can anyone tell me what did we call that? Exactly, diene. So we had like in, when we had only 1 double bond, we had like diene because we had 2 of this. Now what she's asking is that we have like 3 of this. Shouldn't we call that like triene? So the answer is that this is like another class of organic compounds that we're introducing. So now this is the parent compound, and then we call the other category based on this one. Does that make sense? Because now, if we consider that rule, you can also argue we have like 6 carbons. Shouldn't it be some sort of hexatriene?
Right.
Right? And you can use that terminology to name this compound, but now we have like another category that I introduced to you, and I say if you have a ring and you have double bonds that they're, they are like next to each, or like alternating here, right? We call that benzene family. Great question. Any other questions? Good? Okay, so now, so we have one structure for benzene that the scientists recommended. And the model explains why benzene is really stable. And previously I just told you benzene is really stable, accept it from me, this is like the reaction that we have. But he actually came up with a model and an explanation that why benzene is really stable. And the explanation is that if we have like benzene structure that we just had here, and I explained at the beginning of the class, you can also have this structure, right? Basically really similar, but the alternating carbon bonds are different. Can everyone follow what I'm saying? So you can have this structure, so one of your friends can have like this structure, and they are like both correct. And for both of them, the valence of carbon is 4, and then they have like alternating double bonds. And can anyone tell me what did we call alternating double bonds? Conjugated, right? You had like cumulated, that they were like double bonds next to each other. You had like cumulated. What was the other one that you had like 2 or more single bonds between multiple bonds? Isolated, exactly. And I'm going to ask those in the exam, and I gave you like some questions, like come up with like 5 different compounds that they had like conjugated, or like I'm going to also post the solutions of your extra credit assignment in case some students didn't see the video. Anyway, so now the explanation that he gave is that these 2 structures, alternate so quickly that as if you have like both structures at the same time. Does that make sense? So calculate suggested that 6 carbon atoms are located at the corners of a regular hexagon with 1 hydrogen atom attached to each carbon atom. So this we already knew, I guess, based on what they already told us, or your book said. To give each carbon atom a valence of 4, he suggested that single and double bonds alternate around the ring, what we call now a conjugate system of double bonds. And I believe in the next slide, I have his explanation that I just told you. And as we mentioned at the beginning of the lecture, this structure is highly unsaturated, and single and double bonds exchange positions around the ring so rapidly that the typical reactions of alkenes cannot take place. So that's why the reaction is similar to alkanes, and we have substitution reactions rather than addition, because these two structures is as if they exist at the same time, so they don't act like alkenes and they are really stable. Benzene, basically. Does that make sense to everyone? Questions? Okay. Now it's the fun part of naming compounds. So depending on what branch or like functional group is attached to your benzene ring, as we said, benzene is just like the parent of this family, and then you can have like different molecules depending on what is attached to your benzene ring. And I'm not going to read through all of them, but for instance, if you have OH attached to your benzene ring, we call that phenyl. And then if you have like CH2 or like C2H3, you call that a styrene, right? Toluene, cumin, anisole, benzaldehyde, acetophenone, benzoic acid, and aniline. I guess I ended up reading all of those. So I have this policy in the class that anything that I don't know off the top of my head, I don't expect you to know. So I'm going to give you this in the exam, but based on that, you should be able to answer the questions. Does that make sense? Any objections? Anyone wants to remember them and they're upset that I'm giving that? Okay. So, but you should solve some questions, and then I have like homework problems for you, so you solve some problems to be prepared for your exam on Wednesday. So I encourage you to look at them, kind of try to get familiar with them, so when you see phenyl, you have kind of like familiarity so you can answer the question quicker. And the other thing is that if we have bromine atom attached, we call that bromobenzene. So this one you should know, because I feel like you already learned that when you have like an atom attached to your alkane or alkene, you call that bromo, right? And then this is chlorobenzene. This is nitrobenzene. I give you this in the exam too, but I guess it's not that difficult to remember. If you have NO2 attached, you call that nitrobenzene. And ethyl, I expect you know ethyl and propyl, right? From like previous chapters. And what was an alkyl? Anyone? What is an alkyl? Exactly, an alkane with one less hydrogen. And what was the general formula for alkanes? Mm-hmm. Exactly. So this was alkane. If you have one hydrogen less, you call that alkyl. So that's why I expect you to know the other ones, right? Ethyl benzene, propyl benzene. Any questions so far? Okay. So now, one way to name the benzenes was, or like when we have substituents, was like counting them, like 1 and 2 chloro, benzene, and so on and so forth, right? We just had the structure here. The other way for aromatic compounds is the following, that if you consider this X here to be one of your substituents, such as Cl, okay? If the other Cl is located here, you call this structure ortho, okay? So there is just like one double bond between two substituents in ortho structure. If you have the other, so you have your substituent here, XCl, for instance, and then you have the other substituent here. So you have one single, one double bond between them. You call this structure methyl, okay? And then if you have the other structure, if you have your Cl here and then the other Cl here, you have like one double, right? One single, one double bond between them, you call that para. And then we abbreviate those with O, M, and P. So instead of writing, 1 and 2 chloro, chemists just say O. So they would be more concise. Does that make sense? So this one you should remember. And just by solving some examples, I think you can easily do that. Any questions? And the other, we have like these ones here too, I guess these two, because it wants to show you that it doesn't matter. As long as you have one double bond between your substituents, it would be ortho. Okay? So I took like this image from Wikipedia, and this is the other way to show, a benzene structure, to just have like a circle in between. And this also emphasizes that benzene is really stable, and then the double bonds alternate at this, so you can have two structures that I just showed you in the previous slide at the same time. So this is another way to show a benzene ring or aromatic compound, right? So if you have one of your substituents here, if the other one is here, you call that ortho. If it's here, you call that methyl. If it's here, you call that para. And I'm going to ask that in your homework and also your exam. So be prepared to know the differences. And here is just like basically telling what I just told you, that the number of carbons it just specifies. Any questions so far? Good. Okay. So I had like more materials to cover, but let's do the attendance. So my QR code membership, the free trial expired. So before me creating another account or like try to think of ways to get another free trial, because I don't want to pay like $350 to do this, for a year. So just bear with me this session, and then I think of a way for like next sessions. So I'm going to solve some problems, as I mentioned, and I try to have your study guide sooner than later, and I post an announcement to tell you that I posted the materials. So anytime you have any questions, just feel free to email me or like come to my office hours, or if you have problems with the course, just like email me, and I try my best for all of you to do well on your exam on Wednesday.